Hello. So, I asked on the community tab, should I do a super geeky technical video to show how low cut filters cause peak levels to spike? You can't see it here because I'm logged out, signed out, but 85% said yes. There was also some interesting discussion below that post. Basically, everyone getting technical. And I also mentioned, yes, so far I've only showed it, but I haven't explained why. And people are in such disbelief that they just close their eyes and chant, "This can't be happening, this can't be happening," which is the reaction that I keep getting to telling people, yeah, if you cut low frequencies, you're very likely to get a spike in peak level. Hello to Commie Killer 3000. Hello to Javier Garcia. So I'm glad there's a couple of people now because I can just kind of get into it, because I'm going to ask for a little bit of participation, if you don't mind, just to show that everything I'm doing, when I show you how this works, and this isn't just another example of what it looks like when it happens, I'm going to actually explain technically why it happens, which it seemed obvious to me, but still, I don't know. Okay. Certainly people get loud when they think I'm wrong, but suddenly go dead silent when I ask them to show me how I'm wrong. Very good reason for that. They don't know why they think I'm wrong. They just think I'm wrong. And when it really comes down to, when you ask, yeah, but why, but how, then their brain goes, dunno, because they have these theories, and I don't know, sometimes I think that people's idea of how a filter works is it splits the signal into every possible frequency, and then it shifts the phase of each frequency. That's nothing like how filters work. Typically, I mean, there are filters that do work something like that, but not the normal filter. Certainly not something like a minimum phase, a regular minimum phase EQ would not work that way. Mr. Palmer said my silly name. Is it a silly name? Yeah, I suppose it's a silly name. Okay, yeah. Let's just get into it. Oh, someone was asking me about Fourier analysis. Again, you don't need to go that deep. I mean, it doesn't require all of that. This is very straightforward, very simple. Somebody else said, yeah, I think I've had my fill of low-cut filters content, but if you upload it, I'll watch it anyway, which is like, yeah, I've had my fill of low-cut filters content, and which is what I wrote. How do you think I feel? I made a 60-second video, clearly showing the truth, hoping that'd be the end of the matter, yet there's still rank disbelief. Do they think I have something to gain by trying to fool people? Do you? Do you think I have something to gain by fooling people? How far could I go if that was a lie? And what would the benefit possibly be? So it's obviously not a lie, and I've showed the results on the video. So, I mean, what else is there? A mistake? So what's the mistake? I mean, it's pretty clear. It's pretty obvious what's going on. Okay. But peak levels are completely irrelevant since audio clipping is only a real problem in environments of 16 bits or below. No, that's not quite right. Point pi. If anything, if Dan Worrell is to be believed, sausaging the waveform is much more lethal. Can of worms. I'll just say, look, so this is why it annoys me, the reaction to the low cuts videos that I've made. It annoys me because what people are saying about low cut filters, and by the way, Dan Worrell is not one of those people. Dan Worrell understands. He knows what's going on. Like, he hasn't made the claims that I've made in as bold a way as I have, but if you watch like his recent video about plug-in Doctor and how not to use it, he pretty much covered the same ground, and he mentioned that you will get a spike in level when you use a low cut, just in passing. But no one threw the toys out the pram at him. But anyway, I digress. No, he's one of the good guys. But yeah, what annoys me is that this low cuts filter thing, this is like, for me, it's really basic. It's a simple thing that it's easy to demonstrate, it's easy to test, it's easy to see that I'm telling the truth and that I'm not mistaken. I mean, people have all these theories about, oh, it must be a glitch, it must be a bug, it must be because it's digital, it's the quality of the filter. All of that's junk, it's bunk, it's nothing to do with why this happens. And I am going to demonstrate it in a moment. But yeah, why I'm annoyed by it is this is just the tip of the iceberg. The tip of the iceberg. What I'm saying is there's a whole heap of common advice in music production that doesn't stand up to scrutiny. I've been saying this for years, actually. I said that when I was the regular in Computer Music magazine. And I suppose when you say it that way vaguely, people think, what does he really mean? Or is he actually right? And yeah, I am right. And I'm frustrated that we haven't got over this hump. And I just have to let it go, I think. I think that's the solution. But I'm frustrated that we haven't got over this hump because this is like step one, and there's a lot of steps if you actually want to get to the truth. And I mean a meaningful truth that will help you make better music. And that's why I'm here. That is my motivation, is to help you make better music. And I think that is probably, when I say that, I think probably people are a bit skeptical. I don't blame you. I mean, I would be skeptical if I heard someone saying that, I think, even though it's my way of thinking, but it's true. And I have a whole heap of reasons for that, and I'm not going to go into it, but I genuinely think that the world would be a better place with more good music in it. I think we cannot have enough good music. It's good for everybody. And if I can do something to help people make better music, then I'm making good use of my life. That's how I view it, okay? Especially as I went through so much pain to get to the point where I am now. And I'm not saying I'm like high up on some mountain where I know everything and everybody's below me. It's not like that. It's just the fact that it was so difficult. And the main reason why it was difficult to learn what I've learned was because of this kind of thing where everybody says, but you shouldn't do this, but you should do that. And a lot of those things are just nonsense. And they get in the way. That's the problem. They get in the way. That's why I'm frustrated when people say, you must be wrong. Everyone knows that's not the case, Owen. Well, I'm showing you the raw test results. Yeah, but my theory says, forget your theory. I'm showing you the results, the practical results. We can talk about the theory afterwards. Let's read some of these comments. Do you think a lot of the audio myths stem from the fact that music production has since forever basically operated under a guild system? Yes. I don't think music production has, but I think audio engineering has, particularly mixing. I also think you can get very far with very little technical knowledge. And that's part of the reason why I don't even want to be making this video. I don't. I resent the fact that I have to make this video, but I do feel that I have an onus. And I said that in this comment. You know what? I don't actually want to do it. It's just so boring and time consuming. And I don't want technical discussions to be my focus. Well, I'm going to try and not make it boring. I've thought about it since writing this comment. But anyway, let me read this. In my view, the pertinent information is the raw data, the facts, i.e. low cuts will likely result in higher peak levels. And that is a fact, okay? Sorry if you don't believe me. It's easy to test. I understand the burden of proof should be on me, okay? And it's not an easy thing to prove, because how would I prove that? I would have to show many examples. I'd have to show, I mean, if I showed 1,000 examples, there would still be people thinking, I'm skeptical. But maybe those 1,000 examples have been treated some way, or they're all rigged to show what he wants. That's why I say, go and test it for yourself. And some people even say, I have tested it and I got different results to you. No, you haven't. Don't talk nonsense, because I can show you. I've done the test 1 billion times. I've had arguments with people 1 billion times. Billion, not literally. And I'm not new at this. I don't know how to say it in a diplomatic way. I know what I'm talking about when it comes to headroom optimization. It's like an obsession of mine, you know? Something I've thought about a lot for a very, very long time. And when I mean a lot, I mean super, super deep, 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 deep. I mean, I've read big, big technical manuals full of ugly, long words. And that's why I understand this stuff on a level. It's beyond the scope of how much I even needed to understand it, because you get to the point where you're using a sledgehammer to crack a nut because you couldn't get the nut open trying all the reasonable things that you thought would work. So anyway, to continue reading this, explaining the scientific reasons behind why the truth is the truth doesn't change the fact that it's the truth. Ultimately, I don't think the technical insights will help anyone make better music. Interesting intellectually, but no practical value. Which is right. But why am I here? Well, because it's the same reason that I wanted to know the answer. It's just curiosity, okay? And I'm doing this because I feel there's an onus on me, because I was the one who opened this can of worms. So fair enough, I should seal the deal. You know what I mean? Like, draw a line under it. Bring it to a conclusion, because there are people who are just so curious. I think I kind of owe those people an explanation, and one better than, go and search on Google and find out for yourself, because I mean, that's not even easy, to be fair. Okay, there's so much more useful practical information I can put my efforts into instead, stuff that will actually make a difference and help people improve their music. I should prioritize that. After all, I've presented the raw facts. If certain people want to cling desperately to their beliefs despite strong, clear evidence to the contrary, that's their loss, and I'm not here to appease the dimwits. Screw them. I know my angle. Music first, practical over technical, skills over tools. Okay. And I stand by that. That is my position. I'm not changing my position. The reason why I'm doing this anyway, well, the fact that I'm doing it in a live stream tells you something. I don't have a script. I haven't rehearsed anything. I've done a little bit of prep. I've created some test signals, which I'll show you in a moment. But I'm just doing this to get it out the way. I didn't want to spend any more time, thought, or energy on it than necessary, which is why I'm doing it on a live. Okay. So, yeah, now you know where I am. Okay, it's something to do with transients. Prove me wrong. Okay, I'll prove you wrong. Let's go into Cubase. So, a basic understanding that you have to have with any audio, but particularly, it's easy with digital audio, but this is true outside of the digital domain as well. This is true in the analog domain, but in the digital domain, you cannot affect the sound without affecting the waveform, and you cannot affect the waveform without affecting the sound, at least at a technical level. Like, you might not be able to hear the difference. You understand what I'm saying? So you can do different processes to a sound that will change the waveform dramatically, but you can't hear a difference because our ears can't detect it. But the difference is there. So changing the waveform changes the sound, and changing the sound changes the waveform. These things are linked. They cannot be decoupled. There is absolutely no way to change the waveform or to change the sound without changing the waveform. I'll give you an example of that used to make me laugh. I remember seeing in a popular magazine, naming no names, there was a virtual analog plug-in synth, and they looked at the square waveform. So in theory, the square wave waveform looks something like this. Let me make my interface bigger, actually. Can I do that? I can't be bothered to figure that out on the fly. I never do that, so I'm not really sure. I could do that, I suppose. Yeah, so there's the square. And my theory is, it's just that sound. What I'm saying is, if you look at that waveform on an oscilloscope, and this is true in the analog domain as it is in the digital domain, makes no difference. anything you do to the audio to change it will affect the waveform. There are no exceptions. This is an immutable rule. So if you EQ it, you're going to see that affecting the waveform. There is no such thing as an EQ move that will not change the waveform in some way. So yeah, what I saw in this magazine, they were reviewing an analog synth, a virtual analog synth, and they were amazed that the square wave looked like this. Well, yeah, it's just a low-cut filter. And they were amazed that when you play the oscillator at different pitches, the waveform seems to change. And the reason for that is because if you play an octave higher, the cutoff frequency of the low cut is now further away from the fundamental frequency. And so the effect on the waveform is reduced. Okay, very straightforward. And if you had a low pass filter, which many virtual analog synths do, and they might have a setting something like this, again, the effect that has on the waveform will be different depending on what note is played. Okay, this is like, I feel like I shouldn't have to explain this, but here we are. And look, if you didn't understand this before, I mean, I remember when I didn't understand it, but the reason why I'm getting frustrated about it is because people are coming in and telling me I'm wrong, and they don't understand the basics of waveforms. See what I'm saying? It's just... Anyway, let's just get to it. Let's get to the technical stuff. So, all changes to the sound result in a change to the waveform. I'm just going to remove that whole thing. Now, what I have here is a very special waveform. It's just, I call it a flat impulse. You can't see it very well just yet, but I'm going to zoom in and everything, so you will. Basically all this is, it looks like a squiggle, but it's not. What this is, if I double click on this, again it looks like a squiggle, but really what it is, if you look at these dots that make up the image, those are the samples, as in sample rate. So my sample rate is 44.1 kilohertz. So that means there's 44,100 dots per second that make up the waveform. Now you can see all these dots are on the bottom. Forget the green line for now. And then there's one line at the top. That is on the 0 mark here. You can see that goes to 0. So that is maximum amplitude. Now what that does is so basically the squiggly line is approximating kind of the shape that the speaker cone would move in response to this waveform, but it's only an approximation, okay? In reality, well, let's not get into all the depth on that, but basically all we have is a bunch of nothing dots that are silent, and then one dot that's maximum amplitude. This is how Plugin Doctor works, by the way, and what that produces is a flat reading on the spectrum analyzer. In fact, I had span somewhere. Let's have a look for that. Oh, I've got some other plugins on there just because it's in my default, but I'll take them off. So it's literally just raw span here. Voxengo span. And you can see it's just a flat shape. Now people say white noise is flat. No, it's not. No, it's not. This is flat. White noise is jagged. I mean, in theory, if you had a white noise signal running for 1 million years, eventually it should look as probably as flat as this. But in practical terms, white noise is not flat, really. It's theoretically flat, not practically flat. This is practically flat, and it's the kind of the only way you can do that. Okay, hang on a sec. So I'm just going to read these comments. I'm not going to go off on tangents just yet. I want to stick to where we're going. Okay, pink noise and white noise, yeah, pretty much similar things. They're theoretically flat. This is actually flat, okay? I could go into the technicals of why, but I mean, this is getting so boring and so far away from actually helping you to make music that I don't want to do that. So what we can do with this flat impulse is we can use that to measure what an EQ is doing. Okay, so if I don't know, I'll just do a cut. If I were to render this impulse with that cut, what do you think the waveform would look like? Because it cannot look the same. That much we know, that much is guaranteed. Now think about this. The length of this significant part of the waveform, the sample that that has data in it, because the rest is all silent, the length of that is the smallest possible length available at the sample rate, which is it's a 44,100th of a second in duration. So what I'm asking is, if I were to apply this filter, in fact, I'm going to make the filter a bit more exciting, just for fun. It's just, oh, hang on. Now you can see my filter changes coming up on the analyzers, so we know that that's working. Now, if I render that, and I'm just using the Cubase internal render, there's no funny business here, so it's 32-bit float. Could use 64-bit, but it's not going to make any difference. It's just the channel settings, so that means it's taking the plugins that I have on there. Don't need to think about anything else. And before I do that, just to prove, I've got nothing else on this channel. There's no channel strip activated. This EQ is in bypass. There's nothing happening to this. It's literally just a Pro Q3 doing that, and it will clip. By the way, here's an interesting thing. So if I reset these meters, the clip on Pro Q reads as +4 dB. The clip on the Cubase meter reads as 7.8. I noticed this when I did my last video. I believe, maybe it's under certain circumstances, but I believe that there is a maximum level for the peak readout on Pro Q3. So actually when you're seeing +4 decibels on the peak meter, the overshoot meter, it means +4 decibels minimum. It could be higher. So in this case it's 7.8, and that's just something to bear in mind. So that's just like the maximum value that it's going to read back for whatever reason. I'm not sure whether there's particular circumstances for that, because I don't typically go above 0, but since we're in 32-bit float format, that's not an issue. So what I'm going to do is just render that out using these settings, very basic. And oh dear, why does that look like there's nothing there? That's not good. You're messing up my experiment, dude. I'm on a live stream. You can start behaving. Right, I don't know why that's silent. That's certainly not supposed to be silent. Okay, do you know what? I'm not going to render it, because that might be introducing some kind of, it's switching off the internal processing on the plugin because it's a VST3 or something. I don't know. So what I'm going to do is I'm going to create a new channel, and this channel will be no output bus, and I'll set the input bus to be the master out. The master out has nothing on it apart from the span. In fact, I'll even bypass that just in case you think there's something sneaky there. And then I will render this by recording it. So I'm going to record here this impulse, which is just a spike, and it's an almost infinitesimally small spike. It's the shortest duration that the sample rate provides. Yes, it's and anyway, I don't want to get distracted by the comments, the chat. And I'm just recording this with the EQ. Oh, for goodness sake. What am I doing wrong? What am I doing wrong? Let me just test with the speakers on. Is it going silent because it's... because I haven't got the master output on. I accidentally switched the output off. Don't know how I did that. I must have just clicked it at some stage. Okay, again, we're live, ladies and gents. Sorry about that. Let me try the normal way. I'm going to render that and hopefully... Okay, yeah, just me being a bozo. See, anyone can get it wrong and there's no shame in that. I'm not in the least bit worried or embarrassed or anything. So, what we have now is, surprise, surprise, a longer waveform. Well, it had to be a longer waveform, didn't it? That's just logical. Because if we know that the original waveform is one single sample long, in other words, the shortest duration possible, and we know that we've EQ'd it, meaning we changed the sound, then we know that the waveform must have changed. Now, it wouldn't just be a level change, would it? Because then it would be the same frequency response, just at a different level. So it must extend it in time. There's no way around that. I've had people say, yeah, but not in the analog domain. No, listen to me. It's the same in the analog domain. It doesn't make a difference. We're talking at the level of waveform physics. You cannot have two identical waveforms and one of them has had the sound changed somehow, but yet the waveforms remain identical. That doesn't make any sense. That's physically impossible. And if that waveform that we're talking about is, I use the term infinitesimally small, which is not scientifically accurate, but you understand what I'm saying. It's the tiniest burst of sound possible at this sample rate, which could even be translated to the analog domain. It's still a valid measurement. It must be longer. There's no way around that. So it's made it longer, which to me that's perfectly logical, makes sense. Now let's have a look at the actual waveform in terms of the dots, which are the samples that make up the waveform. So there's a squiggle at the start. Oh, it's glitching. Thanks, Cubase. Come on, guys. Okay, there's a little wiggle at the start, but that is, again, it's the green wave the green wave predicts what the speaker cone would do in response to the sound. Essentially, I mean, that's a lazy way of explaining it, but it works. Okay, also, of course, we clipped. I could normalize this. It's not going to make much difference because I thought I could turn it down, but apparently that's not so simple. So let me just do a quick normalize on that. Okay, fine, that's done. So there's our peak, the original peak. Now that went higher, didn't it? Because I boosted a certain frequency or whatever. All of this information here is the EQ. Do you understand? It is the EQ. That there literally is the EQ. I wonder how far that goes on. Okay, so if I were to silence this, how would I silence it actually? I think I've got a key command for that actually. Yes, okay. What have you done now? Right. Yeah, it's because I'm zoomed in. We then end up with the original waveform. Guess what? No EQ. It's gone back to being flat. Why? Because EQ is gone. Why? Because I silenced it. I've just done an edit undo. So there's the EQ curve. I'll show on span. I think it looks a bit nicer. There's the EQ curve with the tail. When I remove the tail, how do I do that? Control Y, Control Z. No, Control Shift Z. Yeah, there we go. Then it goes back to being flat because I've essentially deleted the EQ because all the EQ is that tail. I'm going to check the chat. Oh dear, my screen's glitching. Oi, Victoria V. Victoria V. Never know how to pronounce some of these names. Shout out to Dubious Junglist. Okay, yeah, I'm trying not to get sidetracked by the chat. So, like I said, you cannot change the waveform without changing the sound although you can change the waveform without changing the sound in a significant way that you can hear, fine. On the other side of that, you certainly cannot change the sound without changing the waveform. It's impossible. So let me ask you this. This is an interesting theoretical question. Do you think that a low-cut filter knows whether or not it is processing a frequency above or below the cutoff? Do you understand the question? Does the low-cut filter listen? So if I have a low-cut filter set at 50 hertz with a steepish, let's say 48 decibel slope, 48 decibels per octave, and I have a sine wave up at 1K, 2K, 5K, whatever. Hello to Rodrigo. Do you think the filter cares where that sine wave is on the spectrum? It doesn't know, it doesn't care. All the filter does is act on the entire signal. Okay, now what is the entire signal? This is where it gets interesting. So, going back to my flat impulse, let me take that EQ off. Here's the flat impulse again. I also have a sustained sine wave. That's at 1 kilohertz, just like in my video, the one that people think is fake, that it's not. Now, if you look at the waveform for the sine wave, guess what? That's made out of samples too. So what do you think the EQ does to each of these samples? It does the exact same thing to these samples, every single one of these samples, as what it did to the impulse, the single sample. So, what did it do to the impulse? Let me go back to that. It added this stuff after it. Okay? It took this level, and I suppose it boosted that level. In fact, that's an interesting point. Do you know, maybe I should do this with a low cut filter. I think that's a better idea. So let me go back. I'm going to kill that test channel. I'm going to go back to the flat impulse. Okay, so we're back to a flat impulse. Now I'm going to put in a low cut filter. Would anyone like to give me a value for the low cut filter? It really doesn't matter. There's no value that you can put this filter that doesn't change the waveform. That is a given. That is an absolute given. It's impossible. This is just basic physics. If you change something, it's changed. There's no way around that. You cannot change something and have it not be changed. 440 hertz. Well, do you know what? It's a silly example, but why not? 440 hertz. 150, 15, man. It doesn't matter. It really doesn't matter. I'm gonna go with this one actually, because why not? Slope. Anyone want to give me a slope value? Actually, do you know what? More people type frequencies, and I'll do like an average, or I'll do if someone types this. If I see the same one typed twice, the first one that I see typed twice, I'll go with. Not if it's the same person. Oh, 150 hertz is enough to leave room for the subs. Oh gosh, give me a break. Some of the theories I'm hearing, and I've been hearing them for years. Oh, it's been a long time. I'm going to do 150 hertz, and I'll do 24 dB. Yeah, 6K. It doesn't matter anyway. It doesn't matter where I set this. This is just, it's not to prove a point. Literally any setting I use will give the same result in terms of what I'm showing here. So I'm going to render that, normal render settings, no fancy stuff. Now I have the same impulse with the filter on it, and this time it hasn't actually caused it to peak higher. Looks like that's slightly low, although it's hard to tell with the naked eye. I actually keep in my studio, I can't find it now. Bozo. Ah, here it is. I keep one of these. And I've had it a long time, actually. I've probably had this since I was a teenager. I don't know if you can see that on the cam. I can't see myself, actually. But anyway, this is one of... yeah, can you see the cam? Oh, I don't think my cam's even on, is it? Oh, I don't know. Nah. Where's that? Video capture. There we go. Goodness me, I thought you could see me this whole time. Okay, now one of these. You know, the shatter-resistant Staples ruler. And oftentimes, because it's transparent, I can hold that up to the screen and get a rough idea if something is, you know, level or not. In this case, now I'm pretty sure that has reduced in level, that peak. But although the peak has reduced in level, that's not the only thing the EQ has done, of course. Of course it's not. Otherwise it wouldn't be EQ. This is what EQ is. So this tail after that point, and it's quite a long tail actually because it takes a while to get to 0. It's not easy to see that, but yeah, look, if I zoom this way, you'll see all of this is the tail for that high pass. So again, look, here's the result. You can see the high pass at 150 hertz on the analyzer. Get to span as well because I think that's a nicer view. This is the rendered version. If I were to delete the tail, that high pass would disappear because the high pass is the tail. The tail is the high pass. So, delete. Right, which means this is going to go back to being flat again. There's no way it could not go back to being flat because that flatness is what the one sample at maximum level was. Well, it's not at maximum level anymore, is it? But so yeah, I mean, I've lost a little bit of level, but the theory is the same. Okay, I've put that tail back on. So there's the high pass tail. Now, what I'm trying to explain is this is what happens to every single sample in the sine wave. Where's my sine wave? Goodness me. Every single one of these samples goes through this. So whatever the value is, the starting value, imagine the distance between this value and this value, or the difference between this value and this value. That's what will happen at each stage. Not sure I can make that any clearer. I'm trying to go slow enough so that the kids at the back can understand, can follow along. But I also don't want to go so slow that it's completely boring, because this, I mean, I am interested in it. It's my curiosity. I do find it interesting, but I tell you what, it doesn't help you make better music, for goodness sake. It doesn't. All you need to know is put low cuts on, you're likely to get a higher peak level. That will help you with your music. You don't need to know why. Just the fact that it's the fact should be enough. But anyway, I'm repeating myself and I'm ranting. So look, I have another test signal. And this test signal is a single cycle out of the 1 kilohertz sine. Because that's all that is. That sine wave is just this cycle repeated over and over. With no pro Q, what does that sound like? It almost sounds the same as the flat impulse. It's not the same as the flat impulse, of course, because it goes up and down like that. In fact, it's a collection of impulses, you could say. It's a strange way to put it, not really an accurate way to put it, but you could think of it that way. You could think of it as a series of impulses at varying levels. Now, what happens after that goes through the EQ is each one of those samples, or I call them impulses, will take on this shape. Let's test that theory. So I shall put the filter back on. Never mind the fact that the test signal is 1000 cycles makes no difference. This is 150 hertz. Okay, fine. Makes no difference. It's a little bit daft that I'm doing it on one cycle for the pedantic people thinking, what's he doing it on one cycle for? But bear with me. I'll do a longer one later. So let's just render that. Has that done what I wanted it to do? No. Doesn't appear so. You know, sometimes odd things happen when you try to do things like render the tiniest block. So I'll nestle that inside a part. This is called a part in Cubase. So I have this, it's like a block, and then the block has that piece of audio inside. Everything else is silent. So I can hopefully render that with the EQ on, and it will, okay, there we go. Now we have a reading, because yeah, otherwise sometimes Cubase just gets confused, or the plugin gets confused, or whatever. So here's the result. That was the sine cycle, a single sine cycle. Why do you think the second half is louder than the first half? They were equal in loudness. This is the maximum level here. This is the maximum level here. This is the silence, the zero crossing where there's no sound at all. Why do you think putting a low cut filter makes the second half of the first cycle louder? It's because the first half of the cycle has tails, not just one tail, a tail for every single sample in the cycle. That's why there is a tail that goes past the end of the waveform. How could there not be? So this is what happens when you use a low cut filter at 150 hertz on a 1000 hertz sine cycle. Now imagine, let me chop this. If this continued and didn't just stop there, the next cycle would come in. Where would it come in? I need to put this on events. It would come in here. So that's where the overlap is, right? And you can see because of the quote unquote phase shift, those no longer align. But this is basically what you get. That added to that, when I hold it in this view, you can see them together. Let me just maximize that. That added to that would be the level. So you can see that the first half of the second cycle, the one I'm holding here, would be even louder than the first half, sorry, the second half of the first cycle, which is over here. Does that make sense? Because these things add together. To me, this is so obvious. It's so straightforward, because I understand how these things work. And it's frustrating when people come and criticize me for showing that low cuts make spikes in level because they have a theory. Your theory's wrong, or at least it's incomplete. It's frustrating that I have to go to these lengths when the experiment shows the truth, and you can do it for yourself. You know what I'm saying? Ha! Let's get back to doing stuff that actually makes music better, please. Do you know what? This is it. I'm ranting now. I'm ranting now. Look. This, like I said, this is the tip of the iceberg. Hello, Klaus. Hello, Old Lost. This is the tip of the iceberg. There's a lot of common advice in music production to do with mixing, to do with recording, to do with creativity, to do with how waveforms work, to do with digital, to do with analog, to do with the differences between those two. That's nonsense and harmful. Okay? The number one barrier to getting good at music production in this day and age, where we have the information highway, is misinformation. And I'm not saying people are deliberately, I know what'll get them, let's tell them lies about low cuts. No, it's not happening like that. It's just that people have a very vague, fuzzy understanding of how these things work. They're not going down to this level. and their model of how it works doesn't line up with reality. So when you do these basic tests, like stick a low cut on a sine wave, you're going to get some unusual results. Well, they're not unusual to me. They make perfect sense to me because I know what's going on with the waveform at the waveform level. It's just what I've just demonstrated. But if you think that the way that the EQ works is it knows what frequencies it's affecting and it's going to leave that one alone because that's above the cut, it doesn't work that way. A waveform is a waveform is a waveform. And these things work by altering the waveform. And you can see how that EQ works. It essentially multiplies each sample by the shape of the impulse response after the filter. That's how we have digital filters. Filters were not invented in the digital realm. They were invented in the analog realm. Invented might be the wrong word, but you know what I'm saying. There's so much more. And I'm frustrated because I want to get that information out there because I know that this kind of nonsense is making it harder for people to make good music. Who does that benefit? It doesn't benefit me. I don't want people to struggle to make good music. That means there's less good music in the world. That's not good for me. It's not good for anyone I know. It's not good for my neighbours. It's not good for my family. It's not good for anyone I care about. It's not good for anyone I don't care about. You know what I mean? It's just, there's no benefit to me for that misinformation to be spreaded. That's why I want to challenge it. And like I say, this is the tip of the iceberg. There's so much beyond this. And I would like to just move on. And I know, I'm just going to have to accept it. There's always going to be that contingent of people who are like, no, I know better. Sorry, you're wrong, Owen. That can't be right. I heard that you can't do this because of this, and I understand that it's because of phase. You don't know what phase is, boy. Sit down. Okay? Look at the results of the experiment. That's what matters. What happens is what matters. In science, you look for predictability based on repeatability. Okay? That's how it works. God, I feel like I'm being a bit condescending now, a bit patronising. I don't mean any disrespect. It really frustrates me because I really care about this stuff, you know? I've dedicated my life to learning how to do this stuff better, okay? That's how I've ended up in these rabbit holes because I quickly realised that no one's got all the answers. I don't even have all the answers. I'm not even claiming that, so don't even think this is me being arrogant or big-headed or whatever, because I'm sure there are many things that I'm just as wrong as this about that I just haven't discovered yet because it's vast, man. This is not simple. There's so much to music production, so much detail in the technical theory and all the rest of it. I mean, even on that debate where Projector was saying, oh, you used the saw wave because it's a minimal power waveform. I'm not sure that that's true. I'm not confident enough to say he was wrong. Maybe he's right. He's probably right. I just don't know. So this is what I mean. There's holes in my knowledge. And I mean, I'm missing some basic skills as well. Like, I'm not that great with a microphone, I'll be honest. I don't have much experience. I've not used that many microphones, probably... certainly under 100, well under 100 microphones in my entire life, which is not. It might sound like a lot, no, probably under 50 even. Considering I'm an engineer, I mean most engineers are microphone junkies, and I'm not. So I wouldn't know how to mic a drum kit. I mean I have an idea, but I haven't had that experience. I've never had to do it. So there's plenty I don't know. I'm not being arrogant here. We all have our holes in our knowledge. That's fine. I'm not in the least bit embarrassed or ashamed about that. And neither should you be. Neither should anybody be. Because I think that embarrassment and that shame is what blocks us from learning. Actually, I don't care about microphones in that sense because I don't use them that much. I don't use them to that degree. So that's why I don't know about it. And miking drums is just not something I would do. Nah, it's just not something I would do. if I needed drums recorded, I would hire someone to help with that side of things, because I know what my expertise is, and it is kind of all the dance music-y stuff. You know what I mean? Like headroom optimization, I'm really into that. Mix downs, I'm really into that, but again, specifically for modern electronic type music. And sampling and sample manipulation, MIDI programming, synthesis, sound design. Those are kind of my specialties. And composition and music writing. But again, so I can compose music like chords, melodies, motifs, I can do counterpoint, all that kind of thing. But I would struggle to orchestrate for an orchestra. I don't have that skill set because I've never needed it. Or I've never needed it to that level. I've been able to get by copying or cheating one way or another. You know what I'm saying? So we all have holes in our knowledge, especially when it comes to the technical stuff, because some of it's just so dry and so boring. And you think, well, what relevance does this actually have to my music? So, yeah, look, that's my position. I don't really want to be doing technical videos like this, which is why I've done it as a live stream, and I refuse to actually sit and script and plan and record and edit and do a thumbnail and, forget all that, man. It's not worth it. It's not worth it. Please, if you've come here out of curiosity, that's fine. I respect you for that, okay? I have the same curiosity. But please, let's not get confused. This is technical jargon. It's technical nonsense. I mean, it's not nonsense, but you know what I'm saying. It's extraneous. It's extracurricular. It's after hours. It's not going to help you make better music. It's not. If you're wondering where to focus your energies to be able to make better music, and we should all be asking that question, no matter how good your music is, you should be always asking that question. How can I make better music? And I do obsessively. This is not the area to be focusing on how the filters work. Who cares? Who cares? Please, just look at the result. Use the bit that is helpful, knowing that low cuts can mess up your headroom. And again, that might not even be helpful. Like someone made the point, it's not all about headroom. Well, it might be. It might not be. That's your choice. I'm not here to dictate to you. You've got to be. You've got to obsess over headroom. That's your choice. You can if you want. I don't take issue if you choose to obsess over headroom, and I certainly don't take issue if you don't choose to obsess over headroom. And to be fair, me personally, I did say headroom optimization is one of my specialties. I don't use that knowledge on every project because I don't need to. Because some projects, it's not about the loudness thing. You know what I'm saying? Loudness is obviously not the be-all and end-all. I mean, everyone knows that, I think. Okay, tangents and tangents. So, yeah, I did say I would show that on the full sine cycle. That's the one thing I haven't done. Let me just do that quick. Blah, 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 blah. So from this, we kind of know what to expect if I render the entire sustained sine wave with this EQ. And in fact, I will again, I will nestle that. By the way, this is a 1000 kilohertz cycle, and I'm at 120 beats per minute, which means that wherever I cut, that cycle is at the start. If I cut on a bar, because 120 into 60, you know what I'm saying? The maths works out that I'm always crossing the zero crossing at the bar integers, so don't be concerned by that. It seems a little bit out of phase. How did that happen? Hang on, let me just... that's because Cubase is just... I used the Cubase detector and it's a little bit skew with. It might actually be a visual glitch, so don't watch that. But okay, if I loop this, it will just sound like a sustained sine wave. That's really my point. Let me just take off the filter for a moment. Oh gosh, don't forget to turn down the volume, Owen. Okay. So it sounds like a continuous sine waveform. Not something I enjoy the sound of, but whatever. Now let's put the filter on. It still sounds the same. Oh look, that immediately thinks it's peaked, which is my experiment. And you've seen me do it here live now. No funny business. By the way, it doesn't sustain, of course. Why would it? Because we know that that frequency, 1000, is nowhere near the cutoff. When you play it for the first time, it does, because this is about how it interacts with the waveform over time, because that's what EQ is. It's in the time domain. Now let me render that, and you will see. Actually, how will you see? Because I started off with a maximum amplitude sine wave, so I'm going to have to turn that down, the render, because it's 32-bit. It doesn't actually clip. Although that does make it harder to see what's going on a little bit. But you get the idea here. It's not stable anymore. See? It's not stable. How could it be stable? It stabilizes, yes. How long does it take to stabilize? Guess what? We have a measure for that, don't we? It's this. That's how long it takes to stabilize. The length of the high pass filter, because the high pass filter inherently has a length to it. It's a time domain effect. That's how long it takes for the filter to stabilize, and that's how long it will ring out at the end, which I didn't render it with space on the end, so let me do that. So I'm going to again nestle that waveform inside a part, which means we have just the plain sine wave. I've gone back to the original channel, so this is the plain sine wave, no processing, inside an empty container. So it's silence, then it's the sine wave, then it's silence again. The Pro Q3 is on with the cut at 150 Hertz. When I render that, initially, that impulse, the filter, the low cut filter, is acting on silence. What does it do to silence? Anything times 0 is 0, so it stays silent. Okay, it's multiplying. But as soon as you get to the sine wave, this starts to happen. So you can see, actually, yeah, it is quite clear from this view, because what you can see is that this cycle has gone above. Basically, this line is the 0 dB point, which you can see if you go further into the waveform, it touches the edge at the top and the bottom. But if we go to the start of this waveform, it starts quiet, where it's being multiplied by the high pass filter impulse, and then this one obviously is clipped, this one has 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 clipped. This one, I'm not sure, maybe. This one looks like it's clipped. Sometimes the visuals aren't perfectly accurate on this, so who cares? The point is, it's clipped in several places, okay? It's gone over, in fact, and we'll know the reading for that just by playing it back and looking at the meter. Oh no, because, sorry, I've got a pan law on, so that's doing funny things. So, yeah, it says -2, but the actual value should be -3. So if I reset it midstream, it'll say -3, but if I play it from the start, -2. So that shows me that it's clipping by 1 decibel. Even though the frequency should be unaffected. It's only unaffected after the multiplication at the start. And then it's affected again at the end. People said, well, you can't have phase shift on a pure tone. What do you think fleeting phase shift is? You think it knows whether it's a pure tone or not? Give me a break, guys. Come on. I'm going to break up with EQ. Please do. Do you know what? I did this series on my channel, The Way of the EQ Chameleon. And the first thing I explained is that there's a cost to EQ. It's not perfectly transparent. It might sound that way, but it's not, okay? It is compromising the fidelity at that microscopic level. Normally that obviously doesn't matter. I'm not saying never use EQ again, but I tell you what, you wouldn't do badly to be using EQ as little as you can get away with. You probably will get a much better sound. Same happens to be true with distortion in the digital domain for a whole heap of other reasons. This is what I mean. I mean, there's how far down the rabbit hole can you guys go? Because I'm willing to go all the way. Like I've learned a lot of this stuff that no one's talking about. And when I do talk about it, they criticise me and say I'm wrong when I'm not. And they give me all this theory which is wrong, or it's incomplete at best. And I have bolder claims than this. I do, and they're right. And I know they're right because I go to these lengths to check, to understand. Because I'm curious. Not like certain people who come and say, well, I'm curious, but you're wrong, Owen. Really, how am I wrong? Why don't you show me? Bye. Give me a break. All right, I'm ending the stream. Thanks, guys. Actually, I should read a little bit of the chat. You say under 100 mic is a little. I've only used a single same microphone for over 10 years. Yeah, but I'm an engineer. If you're an engineer and you've only used one mic, so you're a bad engineer. It's always more fun to just make music, but you'll find yourself back here neck deep in this technical stuff if you want to improve. No. Sorry, no, listen. Technical knowledge is not what's going to get you to improve. It's not what's going to help you to improve. It's not. I should know, okay? My technical knowledge is deep. I think I've demonstrated that here. Practical knowledge is what will help you improve. Practical knowledge, not necessarily technical knowledge. Sometimes there's a technical aspect to the practical knowledge. Sometimes there's not. Sometimes there's a practical aspect to the technical knowledge. Sometimes there's not. So there's crossover. But do not get confused. You do not need technical information. You need practical information. If you're given two books, one's full of practical information, one's full of technical information. If you're given two books, one's full of practical information and one's full of technical information, go for the one full of practical information. Unless it's written by one of my critics, of course. Ha! Because they don't know what they're talking about. Most videos I've seen trying to disprove your point have used audio with most of its information below the high pass cutoff, if not way below. Yeah. Again, to just reiterate the point. I'm not saying a low cut filter can't save headroom for the billionth time. Of course it can in certain circumstances. Like, obviously, if you set your low cut filter at 20 kilohertz, you're probably going to save headroom. Yeah, I think that's fair to say. But for the usage that is recommended, everyone should low cut at 20 hertz. Everyone should low cut at 50 hertz. Everyone should give me a break. Give me a break. It doesn't stand up to scrutiny. It doesn't work. Just test it, okay? Just test it. And don't tell me you've tested it and you haven't. That just gets me annoyed. When people call me disingenuous and then they come and they're being disingenuous with me, no, that ain't the